Hi students, this is Mr. Yang. In this video, I'm going to talk about your question number 8 in homework 4.14a, which is about quadratic story problems. Here's an example of a question 8. Your numbers may be different, but the idea is the same. A box with a square base and no top is to be made from a square piece of cardboard by cutting 3-inch squares from each corner and folding up the sides. Well, this sentence itself is already a bit confusing. So the basic idea is you are going to start with a piece of cardboard, which is a square shape. And in order to make into a box that, here's a look of a box, is basically saying all of these sizes are actually folding up from this piece of paper. So you're actually cutting out little corners. So you're going to cut out a little square corner right here. So these are the actual cuts. You're going to cut out another little corner right here, another little corner right here, and another little corner right here. So you're cutting 3 by 3 squares out. So that's a 3 by 3, 3 by 3, 3 by 3, 3 by 3. So you're cutting out 4 corners. Okay, and then here's what you're going to do with the rest of the piece. The rest of the piece actually looks like this. Then fold them up along these edges. And because that's a 3 and that's another 3, they're actually going to meet. So this becomes the new base for your box. And this part is going to be folded up. That part is going to be folded up, here folded up, and that folded up as well. Which basically means the height is going to be 3 with this box. And then you have this new base, and we can actually call them S. Or actually, let's not call it S. Let's say the original piece of cardboard, because the question is actually asking how big a piece of cardboard is needed. So as soon as we know a side, we will be able to calculate how big, because both of these two sides are going to be S. If we know S, we can just multiply them or square them. That's going to give us the area of the original cardboard. Now, in order to calculate, we are given another information. The box is to hold 12,288 inch cube. Well, after you take away a 3 on the left, another 3 on the right, the base of the cardboard is S minus 2 times 3, because you have a 3 on the left side and a 3 on the right side. So this is the only part that is actually left. Let me actually change to the same color. So again, the base is blue, and that is going to be S minus 2 times 3. Then the other side is the same thing. You cut out this portion of 3 and another portion of 3, so you're left with an S minus 2 times 3. And that is the side of the base. The base is also a square shape. So now we can actually calculate the area of that base, which is S minus 6 times another S minus 6. But in order to calculate the volume, because now it's saying the box is to hold that much, the volume of a rectangular or square prism is the base, well, the length times width times height, or in this case is side is the base area times height. We already represented the base area, which is S minus 6 times X minus 6. Now the height for this question, since you're folding out from these little squares in the corner, the height is actually a 3, so times 3, and that is going to be 12,288. So let's start solving this. S minus 6 times X minus 6, if you open the parentheses, do your distribution, that's going to be S squared minus 12S plus 36. And the whole thing is being multiplied by a 3, and that equals to 12,288. Let's open the parentheses. 3s squared minus 36x plus 108. So we're going to minus that number over 12288 equals 0. 3s squared minus 36x, s, then minus 12180 equals 0. everything could be divided by a 3. So s squared minus 12s minus 4060 equals 0. You can either use your quadratic formula or you can choose to factor. So each parenthesis is just going to get an s because it's just an s squared in the front. And two numbers need to multiply to get a negative 4060, and they also need to add up to a negative 12. The two numbers will be a negative 70 and a positive 58. So one answer is going to be a 70, and remember we're solving for the side length, which is 70 inches. The other is a negative 58 inches, which clearly that does not work. Okay, so the final answer for the side is going to be 70 inches. But the question is asking how big a piece of cardboard is needed. It's going to be a 70 by 70. You actually put in the units, 70 inches by 70 inches. So it's actually a question very similar to our frame question. Just the corners cutting out little square is a bit confusing. So that is question 8 for your homework. Thank you.